All right, guys, we're trying something new. What that means is you are going to watch this video in its entirety instead of little broken down pieces, and then your target will be at the end. What this also means is that you need to follow along either in your workbook or on your own sheet of paper if you did not pick up a workbook. If you did not pick up a workbook, I still encourage you to go to the school and pick up a workbook. Just set up a let me know you're coming and I can make sure that it is in the front. You don't even have to come in. We can get it to you on the outside. So highlighted in the top here will be the pages that you need to go to. So in this case, page 60 in your workbook is where I get all of these problems. We're starting a new unit. We're going to be talking about quadratics. So with the start of a new unit, means that there's going to be some vocabulary we need to know. So if you want to hit pause right now to write down what I have written down on the left-hand side, this would be a great time to do that in your workbook. So again, great time to do that. I have this set up as if it were your workbook, so hopefully you can do that as well. A quadratic function is anything with x squared. There's two different forms that we're going to talk about this unit. Today, we're actually going to hit on vertex form, but there is something called standard form as well that we will talk a lot about for the remainder of the unit. So I wrote them both down there so that you have them. Then we need to know what a parabola is. We need to know what the x-intercepts are, axis of symmetry, y-intercept, and a vertex. So I have color-coded them, but if you cannot see the color coding difference, the vertex is always either the bottom or it could be flipped the other way and it could be at the top, but it's always that point of change. It was going one way and then it changes to the other. X-intercepts is exactly what it says. It's where it crosses the x-axis. Notice a parabola could have two of them. If you look over at the example in example 1, it only touches once on the x-axis. And if I were to draw it, let's say way up here, notice it would never cross the x-axis. All of those things are possible for a parabola. The axis of symmetry, so art folks, that one should kind of ring a bell there. Symmetry is where one side is symmetrical to the other, meaning it looks the same. If you were to fold on this dashed line here, on the left-hand side here, it's in this color. If I were to fold on that line, the parabola would look the same. It would touch each other. If it was wet paint, you know, one side would draw the other. A y-intercepts where it crosses the y-axis. It will always cross one time somewhere. And so just make sure that you know those vocabulary words. And then let's dive right on into why we need to know those things. So your first example says describe the transformations of a parent function and then graph the function. Okay? Remember, you can always use Desmos to graph. So if you're struggling with the graphing aspect, open up Desmos, no problem. But these are not too difficult to graph on our own. All we need to know is the h, which is the number inside the parenthesis, and the k, which is the number on the outside. And it's always the opposite and the same. And this is going to be our new vertex, the new vertex. So notice that if it's real plain, it starts at 0, 0 because there's nothing inside and nothing outside. So it starts at 0, 0. My new vertex here, the opposite of -1 is 1. The same as +2 is 2. My new vertex is 1, 2, which puts me up here. That also means that I went right 1 and up 2. And if you recall from 1-2, if you did those notes at the beginning of the year, they're the same transformation. So right 1 up 2. And there's my same parabola. Ta-da! Example 1 is complete. Oh, I lied. It says describe the transformation. So I would say that it went right 1 and up 2. So I said it out loud, I just didn't write it. Right? What if I want to put all of the vocabulary words to use? There were two words that were not shown before, and that's max and min. So your vertex is either a maximum or a minimum, depending on which one it is. So which shape your graph makes. All right, so if I am struggling and I don't know what the shifts are there, I can always graph it in Desmos. I know that this is going to be left 4 and down 5 and reflect across X. Because I memorized 1-2 when we talked about 1-2 and all the transformations. I know that many of us have not done that. So what we're going to do instead is go to desmos.com and we are just going to type that in. So X plus 4 quantity squared minus 5. My new vertex is at -4, -5. And I see that -3, -6 is a point. So back to my notes, which you should be following along in your workbook as well. I'm going to go to -4, -5 as my vertex, and it is reflected down, so it points down this way. All right, so that means that my vertex is -4, -5. That one was easy. If you missed that part, sad for you, because look, ta-da, like, that's it. Desmos gave it to me. All right, axis of symmetry is always really easy. It's always x equals, so always write that. X equals, and it's always going to be x equals whatever your x value is there. So in this case, x equals -4. And if you think about that, well, right here's the middle line where if I cut it in half, one side looks like the other. And so to write a vertical line, we always say x equals. So do not forget that x equals part. All right. We want to know, is the vertex a max or a min? It is at the very top. So that is the highest number that graph will ever be. Since it's the highest number, it is a max or maximum. And last but not least, domain and range, which if you recall, we did last unit. So you will notice, as always, math builds upon itself. If you have been with it since last unit, this becomes easier. If you kind of slacked off and trying to figure out what to do in life, this may be a little harder to remember or understand how to do. For domain and range, you're thinking about how wide does the function get? So as it's going down, is it getting wider and wider and wider and wider and wider? The answer is yes. So the domain, hey, I'm gonna give you a really big clue here. Anytime you are asked for the domain this unit, please write -∞ to infinity. A quadratic's domain, spoiler alert, this entire unit's on quadratics. A quadratic's domain is always -∞ to infinity because it's always going to get wider as it goes. Even if it's pointed up, it's getting wider as it goes. Okay, now the range is different. The range is bottom to top. So notice how this one's turned upside down. That means that the very bottom is -∞, because it's just going to keep going and going and going and going and going. Okay, and then where is the top at? The top is at -5. We will always close that off with a bracket because it is included. There is a point there called the vertex. So, parenthesis and a bracket. Side note, if you had one that was turned this way, so let's say that this was at some x value and let's say the y value was 1. The range here would be 1 to infinity if it is turned up. So like if it is pointing up, that's how I would write the range for a parabola opening up. All right, 2 of our 4 examples down, 2 more to go. The next 2 require more algebra and less graphing. For some of us, that makes us sad, but bear with me. I'll try to make it as doable as possible. Okay. All right. So I'm going to go back up to reference an equation here. I am going to reference this vertex form for this example. So I have it memorized, so I'm going to write it again. So y equals a times x minus h, quantity squared, plus k. H and k are really easy. That's the vertex. So where there's an h, I'm going to put 1. And where there's a k, I'm going to put -4 because that's my vertex. The other point that you are given is where you're going to sub in x and y. So my x is -2. My y is -1. Notice I do not have a. Don't forget your squared. I do not have a, and that is okay because that's what I'm going to solve for. Okay, so solve for a. Yay, math. PEMDAS says I need to do what's in the parentheses first. So -2 minus 1 is -3. Then PEMDAS says I need to do the exponent. So what is -3 squared? That's -3 times -3, which is +9. And last, actually there's 2 steps. So I'm going to add 4 and get 3 equals 9a. And last step is to divide by 9. And if we are good with fractions, we know that that equals 1/3. If we are not good with fractions, we do have Desmos that will help us. If I type in 3 divided by 9, and then I hit this little fraction button right there, it'll reduce it for me to tell me that it is 1/3. So calculator can be your best friend if you know how to use it. Now we're ready to put all of that together into a vertex form. So what is vertex form? I want my final answer to look like this one from our last example. Okay. I have enough information here to do that. So f of x equals, or if you don't like f of x, because you're like, what is that? That's confusing. All right, let's not use it. Let's say y. Y equals, well, what is a? We just found a is 1/3. And then x minus h, so x minus 1, because h was there. And then -4 for k. This is my answer. How do I check my answer? Like, what do I do to check it? I go to Desmos and type that function in. So 1/3 x minus 1 quantity squared minus 4. All right, is my vertex at the right spot? So 1, -4, go back to your work, look. 1, -4 is the vertex. All right, cool. Do I have the point -2, -1? Well, let's look. -2, -1 should be like right there. Hey, look, that point is on my graph. So yes, I am correct. And I have finished that problem. Okay, we are ready for our last one. Please notice we are skipping example 4. I repeat, you are skipping example 4. So for example 5, we're going to have a function who the only translations that it has are to the right and down. What this means is our vertex form, it does not have a stretch, it does not have a compression, it does not have a reflection. Therefore, a is 1, and I don't even have to acknowledge it. Because remember, if I just put 1 times that, It's just that number. All right, to the right is actually minus, so minus 2. Down is minus 5. You can also think about that. What is your vertex if you go to the right 2 and down 5? Well, you're at 2, negative 5, and I plug that in to the equation. All right, that is vertex form. Boom. The problem, however, is it wants it in a different form that we have not talked about. And that's okay, because this is the form we're going to talk about the entire next section, so next week. But how do I get that form? How could I do that? Well, if you remember, x minus 2 squared is really x minus 2 times x minus 2, and then minus 5. What does that look like? Oh, she's drawing the box. What's that mean? All right, so your Algebra 1 class, I hope you did the box method. If you did FOIL or you did distributing, please keep using that method. But I know a lot of us learned box method for x minus 2 times x minus 2. So x times x is x squared. Negative 2 times x is negative 2x. Negative 2 times x is negative 2x. And then negative 2 times negative 2 is positive 4. So how do I write my final answer? I combine like terms. There's no like term for the first one. These are like terms, so I'm going to combine them. And then this guy's on his own too. All right, so x squared minus 4x, because negative 2 minus 2 is negative 4. And then positive 4. And then don't forget this little minus 5 hanging out here. All right. So now, last, I write my final answer. Notice that these two I can combine like terms, and 4 minus 5 is negative 1. And that is my final answer. You have completed your first notes through Edpuzzle. And so now you will have your target through Canvas today. So remember, there's no need to do Envision, no need to log on to Envision. Keep everything in Canvas. We're going to give this a try. Many of you wanted to try it this way. So that's how we're going to do it. Okay? You have now completed